Podcast Channel 189. As we approach the 2-year anniversary of the March 2011 earthquake that struck Tōhoku, Japan, we remember the tragic incident and how it affected the country. First, here's Drs. Nam and Gaby to talk more about the earthquake and how it occurred.
Thank you, Dulce. And here's Gaby to talk to us more about how earthquakes occur.
Okay, as we all know, the Earth is made up of tectonic plates. And when these tectonic plates slide and collide towards each other, they create an earthquake. And the tectonic plates are connected edge by edge, and when they're trying to move past each other, they build up so much force that whenever they actually slide past each other, they cause the earth to shake. And the earthquakes tend to normally cause aftershocks that can lead to tsunamis.
Okay. And earthquakes have many effects on the environment. As Gaby once earlier mentioned, there are a lot of aftershocks, especially during the Japanese, which was a 8.9 magnitude, and it caused over 9,000 aftershocks. Earthquakes have caused a lot of devastation and loss of life that is beyond the original event. And one of these effects that it causes on the environment is landslides. And landslides occur whenever the weak soil and rocks collapse during an earthquake. And these landslides usually occur in mountainous and hilly areas. And during these landslides, the vegetation slides downhill, which destroys everything in the landslide slides downhill, and often destroys everything in its path, such as vegetation and habitats for the animals. And in addition, these landslides can also cause massive clouds of dust, which also leads to infection of other animals. And in addition, earthquakes causes tsunami, which are tidal waves that usually occur from the point to other places. And these powerful waves usually start deep in the ocean and usually go unnoticed until they reach shallow waters. And these tsunamis often hit coastal areas, and destroys everything in its path, including trees and homes. And in addition, there are secondary effects that earthquake causes. And in the Japanese one, the most apparent one is the failure for the radioactive plants. And it causes poisonous materials to be leaked into the ecosystem as well as the air. And back to you, Dulce, at the studio.
Thank you, Drs. Nam and Gaby, for your input. Now here's Dr. Jackie to further explain the basics of radiation and how it related to the 2011 earthquake.
Thank you, Dulce. The earthquake and tsunami in Japan caused the nuclear meltdown at Fukushima Daiichi nuclear power plant, causing radiation leaks and forcing the evacuation of thousands of people in the vicinity. I will first provide the basics of nuclear decay and radiation. A nucleus is held together by a nuclear force that is not electrical or gravitational. Some nuclei are more stable than others. If a nucleus is unstable, it can attempt to increase its stability by attempting to increase or decrease its number of protons and electrons. This is the process of radioactive decay. And elements after the number 83, which is bismuth, are naturally radioactive. There are many types of nuclear decay, including alpha emission, beta emission, positron emission, electron capture, and gamma rays. The main radioactive elements produced in the meltdown in Japan were iodine and cesium. The isotopes of concern were iodine-131 and cesium-137. And an isotope is basically an atom with a different number of protons and neutrons. Both of these isotopes decay by beta and gamma emission, so both are an internal and external hazards to humans. The half-life of iodine-131 is 8 days, and of cesium-137 is 30 years. The half-life of a nucleus is simply how long it takes for half of the substance to decay. This means that they will be distributed widely in their environment before they decay, but would also be present in measurable doses important to humans. Radioiodine can cause thyroid cancer, and radiocesium can get into the food and water. And the levels of radiocesium have been found to be larger than regulations allow. Overall, the radiation levels the Japanese people will experience is not significantly high. These amounts will lead only to a 0.2% increase in the chance of having cancer later in life. Back to the studio.
Thank you, Dr. Jackie. And now we have Dr. Alvarez to give his input on the subject.
Thank you. The earthquake caused nuclear accidents primarily at level 7 meltdowns, which is the highest level, the nuclear magnitude of scale, at 3 reactors in the Fukushima Daiichi nuclear power plant complex, in the associated evacuation zones affecting hundreds of thousands of residents. Many electrical generators were taken down, and at least 3 nuclear reactors suffered explosions due to hydrogen gas that had built up within the outer containment buildings after cooling system failure. This earthquake caused a surface energy of mendelevium of 0.5 joules, dissipated as shaking and tsunami energy, which is nearly double that of 9.1 magnitude of the 2004 Indian Ocean earthquake and tsunami. Changes to groundwater geochemistry can be an indicator of changes to the circulating system where the movement, mixing, or increased contact with the weathered materials due to static and dynamic changes to water or earthquake. Determining the causes of chemical groundwater changes can increase in weathering or interacting with new rock formations. There were 7 solutes: calcium, magnesium, sodium, potassium chloride, sulfate, and bicarbonate. Effects on earthquakes have had elevations and drops on certain chemicals, showing that changes were already occurring in the groundwater before the major earthquake even struck. Thank you, and back to you.
Thank you, doctors, for your input. These are the different scientific aspects of the earthquake. Thank you for tuning in to your newscast, Channel 189. Thank you. Welcome to your newscast, Channel 189. As we approach the 2-year anniversary of the
Thank you, Dulce. Thank you, Dulce. And here's Gaby to explain more about the earthquake. Okay.
Thank you, Dr. Nam and Gaby, for your input.